Hi class, are you ready to see live programming using stack? In the textbook chapter 13, there's a project 10 that has this problem where we can use the reverse Polish notation to express a formula. I thought that was an interesting question that almost became your homework, but I decided otherwise. So I'm using this as our like one example to show you some concepts for stack and also other things, actually error handling, and also how to read input from user, because when I look at your assignments, I see some of you are still struggling a little bit because you don't know how to use a certain way, and so I'm showing you one way that you might consider trying. So let's talk about what is reverse Polish notation. In normally this is what we see, right? But in the RP and in this notation, what they do is they will express a formula that's in this form in such ways. So it would have number 10, 4, 3, and then has plus, and then minus, and then so on and so forth. So how does that work? So it will continue reading in numbers, and then when it encounter an operator, it will then use the operator on the last two numbers, and like here it will put the plus in between 4 and 3 and then add them up together. So it's then this became 7. 10, 7 minus, so it encounter an operator, right? So it will use the minus in between 10 and 7, so it becomes 3. So now it's 3 and 8, it encounter the start, so it will put the start between 3 and 8, it becomes 24. 24, 6, put the divide in between 24 and 6, it becomes 4. So that is the how they evaluate or how they put the math expression together. We are going to implement it in a stack. So we would push the 10 into the stack first, and then the 4, and then the 3. We encounter the plus, so we would pop out the 3 and 4, and you can see that 3 actually goes after the operand, 4 is in front of the operand just like before, and we do the math is 7, and then we push it back into the stack. It's exactly the same process, so I'm not going to go through this. If you need to, pause the video and understand this before you continue, because it took me some time to it wasn't like very obvious in the beginning how this works too. So take your time, understand the problem, because that will help you to understand why we implement the code that way. So in words, this is how the algorithm works. When in our program, that's what we are going to write. When the input is a number, we push it into the stack. When the input is an operator, we pop two numbers out of the stack. We place the first number as the second operand, place the second number as the first operand, do the math, push the result into the stack and then you repeat basically the whole process. It ends though, we have to design the end, so we decided the end will when we get the character Q, that's when we end inputting the expression. So I would show you how to do so. Remember, we are basing on the stack implementation, but because right now we are reading in numbers, and so what I did was I went and searched for all the characters, CHAR, and then change it to double because I want to be able to even get double inputs, not just a integer. And then I changed the name because it was symbol, and I changed it to number just so it's easier, for me to understand the code. I just basically in Sublime Text is what I'm using, and so I can basically do it this way using the character and then double and then replace all, and that's what I did to change my class so that it is going I can use it for the RPM function program. I think in Xcode what you can do is call refactor. So for the stack.cpp and start stack.h, that's what I did to adopt the stack for me to be able to use it in this program. So now let's look at the program itself. I wrote a little bit of the code so that you don't have to wait for me to type. Stack out is called RPN. We will read one character, but not every. You will see how I implement it. So we will eat a character because we need to at least read the Q at the end, right? And the operator. We would use 4 doubles. Number is when we get the input, or we can just call it input actually. And then the operand 1, operand 2, and the result. So I've copied the mechanism so that I can have it for reference. So let's start writing the code. This is going to be a while loop because we are repeating these steps when continue to read the expression until we encounter the Q. So we will read the one character at a time in the while loop, and then we will check if the character is equals to is not equal to Q. Then we would keep looping. So inside the loop, the first case is if the input is a number. Actually, I think it's still better to call it num because yep. So if num is if it is a digit, right? Because if C is a digit, it means it's a number input, it's not a operator input. Then we would put the character back into the input stream. For me, this is the easiest way to read numbers, is to not having to process, or that is actually called parse, P-A-R-S-E, and try to construct the double. We don't want to do that. It takes too much time. So what I'm going to do is to put the character back into the cin stream, and then I will read in the whole double, because you don't know how many characters there are, how many digits and the decimal point is going after this. So the easiest way is to read in the double this way. So remember to put back the character C and then read it as a whole double number. And once we read that number, we need to push it to our stack. So we would do a push, num, so on. So next is if the input is an operator, and we could have do else if, but I'm going to do something different to catch when the case that there's an invalid input. So because it's an operator, C is an operator here, we would pop 2 numbers, and it's important is this, the first pop, it will actually pop op2 and not op1, operand 2. If you remember, the first number will go to the second operand, and so on. So op2 will equals to the first pop, and then op1 will equals to the second pop. And then we are going to do the math. So how do we implement it? We are going to use a switch. We will switch the C, and then in case of a plus, we would add the two numbers together. So result will equal to OP1 plus OP2, and then we will break it. I'm going to copy and paste. And then change this to read the different operators. Then I will remember to times this by 1.0 to, because it's a, you don't want to do the wrong calculation. So we are going to catch the other characters here by using the default in the switch. And so if it's not a number, not a digit, not a operator, and not a Q, right? Because Q is also catched before. So we will see out an error message and say that invalid input. Let's just make it easy. And then we will exit here. Now, so once we have the result, we would push it into the stack, right? So that the calculation can continue. Okay, let me push the right thing. The result is what we need to push. And so, right, I think that is it actually. So at the end, after the while loop, that's when we have the result. So we can just do it this line. That's why it's here. So we will see out the result. We will have to do make, sorry. And then we would how about copy and paste that expression. And so you see result is 4. So it seems like it's working, but let's look at the intermediate result to do some kind of debugging to make sure that it's properly done. So I decided to put some debugging in here, and I want to show you a way to use a tag, a debug tag. So you've seen this in the separate compilation. We use something called if not defined, but here we are going to use something similar called if defined. So if the tag debug is defined, we would run this line of code, and so we have something matching up here that we define the debug here because this is defined, so this line of code will be run. So let's try it, and we will use the same well, because I copy and paste the wrong thing, and let's copy and paste this again. And you see the intermediate step is being shown. 4 plus 3 equals to 7, 10 minus 7 equals to 3, and so on and so forth. So it seems to be working well, and so we don't need the debug message anymore. What we can do is we can then comment it out And then we need to do a make to compile it again, and then run the program. You see that once we comment out the define of debug, that line of code didn't happen. So this is one way to turn your debugging message on and off, especially in bigger programs. If you need it, it's a good tool if you if it's helpful to you. Another thing I want to show you here, since we are talking about debugging and exception handling in this module, I just thought I would also add something that that might help you. Is that we can use something called assert. So assert is a piece of code you can insert anywhere in your code to check certain condition is true or false. If it's false, it will exit the program and print out the error message. So I can show you how it works. So we'll do a make, and then we'll basically do it again. And you see, because 1 equals 2 is never going to be true. And so what it does is it say, hey, assert failed, this condition didn't meet, and where it is in line 76. I'm sure your IDE will do exactly the same. So to recap this, you can use the define debug and to turn your messages on and off. You can use it for other purposes, of course, also. And then you can use assert to test certain conditions. And the main is here for your studying purpose. So how do you, we have talked about how to use linked list based stack class to write a program to calculate expressions written in reverse Polish notation. In your project, you have to do similar thing, basically. And so that's why I feel like giving you a demo of something similar will maybe help you with your project. And we talk about how to turn debug messages on and off, and how to use assert. Next, we are going to talk about exception handling. See you in the next video.